So here's a rather deep example. A liquid swirling around in a right circular cylinder container that has radius 2, and its motion is described by a velocity vector field, f of x, y, z equals negative y times the square root of x squared plus y squared I plus x times the square root of x squared plus y squared j. Note, with no k component, there is no up or down motion in the container. In other words, it's just swirling around and doesn't go swirling up and running out of the container or swirling down, run out the bottom. So find the circulation about the top boundary of the surface of the container. We could do this as a line integral around the top edge of the cylinder or as a surface integral, and so we'll do it both ways. So it's a surface integral. First thing we need to do is find curl of f. So here's our curl of f, I, j, k across the top, partials in the middle, and finally at the bottom we have this stuff, so I mean from here, right? So I times the partial of y with respect to 0, well, okay, that's 0. And the partial of z with respect, oh, that's 0i again. Hey, still that before, didn't we? And then minus j times this partial, oh, that's 0 again. And partial of z with respect to this, another 0, so 0i plus 0j, and then finally we get something. K times the partial of this with respect to x, ooh, that's ugly. Trust me that this is correct. And then minus a negative, so plus this partial with respect to y. And so trust me on that part. We wind up with, golly, that's ugly. But I think you can see if I find a common denominator with all this stuff, I get something like 3 times x squared plus y squared, because I get 1 from here, 1 from here, and 1 from here, plus that over 3 times the quantity x squared plus y squared over square root of x squared plus y squared. And remember, x squared plus y squared over the square root of x squared plus y squared is just square root of x squared plus y squared in the numerator. So there is the curl of f. 0i plus 0j plus that simplified k. You have to trust me about the partials there. I don't want to take the time to go through that, but you know how to find partial derivatives, and I don't think I need to explain that. So, we know an outward unit normal vector to the surface is n equals k. Why do we know that? Well, it's like the top of the cylinder, right? The top of the cylinder. Remember, it's a cylinder of radius 2, so just k, right? N equals k. So, and that's a unit vector. So the integrand is the dot product of curl of f and n, which is 3 times square root of x squared plus y squared. The region we're integrating over is the upper surface of the cylinder, so ds equals dA, where r is the circle. Square root of x squared plus y squared is less than or equal to 4. So converting to polar, 0 to 2 because the radius of the circle is 2, 0 to 2 pi because it's a circle after all. And we wind up with 3r in polar. Remember this, what this is. So 3r times r d theta, and trust me, it comes out to be 16r. As a line integral, the vector valued function describing the circle of radius 2 counterclockwise is r of t equals, sorry, that should be r of theta. Not t theta, just theta. 2 cosine theta I plus 2 sine theta j. Remember, that starts at on the positive x-axis and winds up back to itself again because we're going from 0 to 2 pi. And so our dr is derivative of cosine is negative sine, so negative 2 sine theta I and plus 2 sine theta j. And the vector function f is now, remember our f, where did it go? Here it is. That's negative y times r, and this is x times r. So our vector function, this is negative y, right, because that's what y is, times r. we could put in, you know, 2 cosine squared plus 2 cosine theta squared plus 2 sine theta squared. That would work for everyone, I think. And then plus, remember our vector function? You know what, I might need to copy that and bring it down here. So I can see where everything goes. Okay, plus x times square root of x squared plus y squared j. So here's the x from here, and square root of x squared plus y squared. Well, there's the x again, and the y being this goes in there and squared. And notice each radical there just contains the square root of 4. So each is just 2. So we got negative 4 sine of theta I, and plus 4, this 2 and this 2, making 4 cosine of theta j, right? So our f dot dr is, remember this is our f right here, and our dr is this. So when we dot these two together, we get positive 8 sine squared theta, and then plus 8 cosine squared of theta. Golly, that's just 8. And so we have the integral 0 to 2 pi, line integral of 8 d theta, which is 16 pi. And that should be kind of familiar because when we did it the other way, where is it when we got the answer? Here, we got 16 pi, just like we said. So there it is, done both ways. I hope you've enjoyed this. Well, I hope you've enjoyed this, and since this is the last part of our lesson, I'll say goodbye.
Okay, bye.
Bye.